Good, good morning, good afternoon, good evening. Welcome to the presentation of the Mpai Metaverse Technologies version 2.2. Um, so what is Mpai Metaverse the Modern Technologies version 2.2? It is a standard project developed by Mpai. Mpai is the international unaffiliated not-for-profit association based in Geneva. We develop standards for AI-based data coding using a rigorous development process. This is obviously important, but probably even more important is by attaching clear IP right licensing frameworks so that our standards are usable. So this is the table of content of the standard. We have a foreword that introduces Mpai and its method, and we have introduction, the scope, which is where we say what the standard is about, definition, references, architecture and operation is much recommended to your reading. Then we have the actual specification, processes, item, process action, protocols, profiles. We have verification use cases. We have APIs, um, and and two version of reference software and the general guidelines. Um, so, what is the scope? It's there's a standard specified technologies that enable a metaverse instance to interoperate with independently designed clients and metaverse instances implemented in conformity with this MM Tech standard, and also providing a level of security suitable for a virtual economy in an instance. So, what is a metaverse instance? It's a virtual entity. It's a virtual entity populated by processes. What do this process do? They interact. They interact with each other, or they process with processes in other metaverse instances, or with the universe. So here's what you see. We have an M instance. It can interact with the universe or with other M instances. And here is the notion of process that we'll talk quite a bit today about. Process interaction. So we said that we have processes, and processes, well, do things. And the things are called actions. They do it within an instance, but also possibly in different instances. A process interacting with the universe, well, this is a slightly more complicated thing because it involves bidirectional communication and control, whereby the process detects universe objects and then drives their reproduction in the metaverse instance, actuation of objects that are in the M instance in the universe, and coordination of universe objects. So there are quite a lot on this plate, but we'll try and talk about all these things. So we talked about users, about processes, but a very important class of processes are users. Users are processes that represent and are under direct and responsible control of a human. Control, well, it's a word that should be taken loosely because the control can be total. The user does not do anything that the human doesn't want, but the user can have a degree of autonomy. This is part of a standard that Mpai is developing. We are not ready for a presentation, but just to let you know that more is coming. So this is the list of actions. I'm not going to introduce them. I just wanted to let you see that we're actually for communicate, to establish an economy, to execute processes, to export things to the universe, to identify things, to import things from the universe into the metaverse, to find information, to manage items. Items are the objects in the metaverse. I'll talk more about. Locate. What are the things that you can do in the metaverse? You place, you move, you animate, you capture. I mean, several of these things. And it's a very essential notion that we'll spend some time introducing is rights managed. So processes cannot do everything. Processes are bounded by rules which apply to the entire metaverse and by the rights that a process specifically holds. So a process can do things, but not necessarily it can actually do it or may do it for the reason that partly I have already said. So an action cannot be performed because the process does not understand the data of a specific format. It is handling an object, but it doesn't know the format. It may not have the technology that allows it to perform certain things, or it doesn't have the right to perform that thing. So a process action then is what a process uses to ask another process to do something on its behalf. A process action is a speech act. It's a small subset of a speech act, but it is a speech act because this is a simple definition is what a speaker does not necessarily need to use a speech to do that, but it expresses something when they say something such as asserting or requesting. And request is exactly what process action is about. And then, of course, to a request, there will be hopefully a response. Okay, so let's go more in details into details for process action. So we have two components, as I said before. We have the request part and we have the response part. When a request is made, a process gives the times when this process action request is made, and also when it requests, it's requested to be executed, then the action itself, but the action is not sufficient because the action on what, with what, for what purpose. So we have here a selection of prepositions that can be used to put together a complete speech act. Then we have the response. The response, again, we have the time when the response is emitted and the time when the process action request has been performed. And it is of two types. It can be SDK when the process provides the response, and again, this may be accompanied by a series of prepositions, or it can be an error message. So let's go now to the very essential notion of rights, rules, and penalties. So a process may perform the actions that are included in its rights. But then what is a right? Well, right is the ontic verb, the one of the three, may not, must, followed by a process action, a level, in the sense that a right may have been given, may have been obtained at the time of registration. It may have been acquired. I mean, we are talking about virtual economies, and that right may have been acquired, or it may simply have been granted by another process for its own needs. And then the right of status. So not necessarily a right is something that is indeed there or already. In some cases, it's only a model because you are negotiating, saying, I want to get that right. Okay, so I give you a model of that right, And then if everything is okay, eventually the right will have a final status. Um, the actions can be declared admissible by the rules of the metaverse instance, and in that case, the rules are simply the ontic verb, a process action, and a time. So this is what the rule is about. Then we have what happens when a process does not perform according to the rights and the rules. So in that case, the process may be subject to penalties, and a penalty is again expressed by a denominative verb, but this time we only have may not, in the sense that it is not allowed to do something, and the something is the action, and again followed by the necessary complements and items. Okay, let's now go to the types of process actions. So these before I gave the list of actions, the process action is exactly the same list, and I prefer to have a unified specification of what the process actions are. So we have a group of process action that I used by a process wanted to do something. For instance, if a process wants to deploy its own avatar in the metaverse, it will probably have to ask a service on the metaverse to do that for it. If you want to move, similarly. If you want to change the properties, want to have enlarge the size of the avatar again. Then we have the capture from the universe. That is obviously very clear, is what I said at the beginning, that by interacting with the universe, that one thing that you may want to do is to capture something that exists in the universe, convert it into data, move the data into the metaverse, and then use one of these process actions to place them in the metaverse or to move them around. Then we have the third class, which is from the metaverse, you do things in the metaverse. You have actuate, you have add, animate, move, and send. I will give more details about this later because it is an important part of the presentation. So then we have other process action. We have the identification of things. Resolve is an action whereby you can get in touch with another metaverse, because metaverse is like a country. Not necessarily you're allowed to interact with what is outside of your country with another country. So the similar process is here. Then we have a poster, write, change, and transact. These are the process action that are basic to build an economy. Then we have information process action, playing with items, and authenticate and validate, which are, if you want to know what this avatar is, so you may use the authenticate service process action to get that information. Okay, so now we go to the concept of item. Item is, all abstract and quote unquote physical objects in the metaverse are called items. We have general items. We have items related to processes and action. For instance, what is activity data? Well, a process does the things, actions or process action, and all of this may be recorded. When you have event, it's a combination of different process actions. Penalty, we have just defined. It is another data type that exists. Resolution is the information that you send in order to get in touch with another metaverse. Then we have Those are related to human account. It's obviously very important. Personal data is also very important. Then we have service actions. These are the data type that are used um, to ask for information. Then we have quite a few data types for finance. Again, I will delay the presentation because I will give more details later on. We have um, many data types for perception, 3D model, audio, visual, scenes, um, in other elements. Then we have internal state include some data types that are related to expressing the internal state of a human or an avatar. An avatar can simulate to have an internal state, and we may want to have the means to express that. Then we have data types to express space and time concepts. Let's go to another important element. One of the reasons why the metaverse is not taking off at the speed many would like to see, it's because there are different technologies to do different things. Mpai does not want to get into that controversy, and it uses the notion of qualifier. Qualifier tells you what is the meaning of data. Is this data an MP3 data or NAAC data or an AC3 data? So Mpai doesn't care what is the format, and it signals data through a metaverse. So not all, but a significant part of the items that I have described before are represented as objects. What is an object? An object is data plus qualifier. Data is the raw data that people are interested in, obviously, but the qualifier tells you what is the meaning of that data. So let's go to another important part of version 2.2 of the Mpai Metaverse model. Technologies. You have items that can move from a process to another process. So if I am asking another process to do something for me with a process action, you have seen that there are complements followed by items, and so you are transferring the item to another process. Now, you can have an absolutely watertight metaverse, but you can have also a looser metaverse, and not necessarily the receiving process is keen to receive your data because it doesn't have trust in you. So, so we have developed a data type that is called data exchange metadata. It is a container, a rich container of metadata that includes who is sending who is receiving, the type of data that is being transmitted, the legal status. Legal in what sense? Well, this data may have been produced by an AI, and countries are getting aware that there may be a problem in doing that. So we have the possibility to signal what is the legal status of the transfer data. What is the security technology that's been used to transfer from the source to the destination, and what are the rights that are granted to the destination process to do things on the data. Then, so the conclusion is that by using all or a subset of this data type, data exchange metadata, a metaverse instance can define a level of security that's appropriate for the application that they have in mind. Let me go to another point, which is very much related to what we have discussed, rights and rules and penalty. So what is the control that the specification makes on the activity performed by the processors? Well, the answer is very simple. We do not specify anything. Because an instance can decide to verify the full set of activity data, the data type that I mentioned, the log, to make verification when another process is requesting to make a verification, to make random verification, not to make any verification at all. So in other sense, the specification, rightly, absolutely rightly, does not matter with what are the policies that each metaverse may decide, but provides the tools to implement those policies. Let's go now to another part of the presentation, which concerns the possibility to create virtual economies. So here we have the collection of data types that are related to economy. We have the notion of asset. What is an asset? Well, very simply, but this has an impact on the structure of the data. It is an item that can be transacted. Then we have the notion of contract object. I talked before that object means data plus qualifier. So they have zillions of contract. And we don't want to say which contract should be used. Absolutely. So we say that you may have something that you call contract. It has data and it has a qualifier. The bundle of data plus qualifier is called an object. The same for currency. Then we have the notion of license. We have a powerful data type for that. We have provenance, the history of an asset. Service pricing model is something very important that we will focus on in the next slide. Just to help things kickstart, we have a very simple concept that people may want to use as a start, but then we give all the possibility to use all other form of content through the objects. The notion of transaction, I mean, we have very powerful data type for that, and wallet and value. So this is the set of data that we have. Let's see, the service pricing model. It's a data type that defines the rules, the parameters, and the conditions under which a service is offered, billed, chosen, settled, and accessed. So here you have many types of services. We have the service pricing model status. Like for rights, it can be an order, it can be final. So if you are negotiating, the service pricing model status will be order. When you get an agreement, when things are settled, then you have the status will be final. We have asset posting. So this is another important case supporting the case of when you are entrusting an asset to a marketplace and so on. Let us see. So here I will spend a little time to go through protocols. For each process action, we have defined a protocol. A protocol that is available in WDL to help people wishing to implement this. So let's see how it works. We have a user who wants to make a payment through a transaction service. So we have the transaction process action. This is one of the process action. And we have the request part. So it makes a request, and the request includes the transaction. The status is obviously modeled to a transactor service. So we have two cases here. If the transactor service is free, then the users change the transaction status to final and goes to something that is called transacted that we'll see in a couple of minutes. If it is a pay service, now these things get more complicated because now the user sends the transactor a process action request. It's a new one that contains the service pricing model that is obviously the status is model to the transaction service. The transaction service sends a response, and response can be forget it, and then the protocol comes to an end, or it can say the transaction response can include okay, and then it gives a service pricing model that include the transaction, and both of them are status, of course. And in that case, the user does what? It makes a transaction with the value that was included in the service pricing model, and sends a transactor process action request that includes another version of the service pricing model that includes the transaction, but this time the status is final because this is the proof that payment has been made. So after that, we go now to the final part where the transactor service increases or decreases the wallet present in the transaction. There may be many parties involved, and sends to the user the response that includes a service pricing model, but this time the service pricing model has a status final because everything has been nicely completed. And this is in the case, it is a pay service, and now we come to an end. We have another protocol. I think that now things can be simple. This one is when a user wants to communicate, wants to do things with another user in another metaverse. So we have this process action that is called resolve. So we have a resolve process action request that includes to whom this is sent, to which metaverse instance is sent, to which process in that metaverse instance, what are the rights that the user wants to get in the other metaverse instance, and this is sent to its own, let me call it customs. So the resolve A is the customs of metaverse instance A. Resolve A simply relays the request to resolve B, and resolve if the response is no, okay, go to end, and that it's not possible to communicate. If the response is positive, then if a resolve A is a free service, then it goes to again to resolve. If it is pay service, it sends to user A the response that includes a service pricing model with transaction, and again, both are status because we are just at the beginning of the process. In that case, the user A makes a transaction as it was written in the model and sends to resolve A the request that includes the service pricing model, which is, of course, status model, with a transaction which is final because it has already paid. So here in resolve, very simply, resolve A sends the request to resolve B. Resolve B sends a response with acknowledge to resolve A, and resolve A sends to the user, the requesting user, the response including the service pricing model, which is final because it is at the conclusion of the process. So two interesting examples of the power of process action and protocols that have been developed, which are available for machine use in as the WDL code. So I'm coming to the last issues that I wanted to deal with. So we have the case of so we have the case of of actions and items that enable a user to perform action and actuate in the universe items of a metaverse instance. So the process isn't the metaverse, but it wants it to do things in the universe. So we need two sets of things. The first one is a new item that is called R item. VR should tell you something, but I will say more in a second. The actions are those that I presented before. This is from the metaverse that you want to render an item that is in an image instance at a U location. Add is to place this object at a U location. Now you want to animate it. So imagine it is a robot. So you have the notion, the knowledge of how to animate a robot with a string. Then we have move. Now you move the item from one place to another place, and the last is for sending data. So this is what our item is. This is the action specification. The R item is a perceptible object in the universe. It can be of three types. It can be an existing real object. It can be a new real object that has been synthesized, or it can be a perceptible 2D or 3D media item in the universe, and this is the specification. So a use case, simple use case, you have an emergency to deal with emergencies in an industrial metaverse scenario. You have an M location that includes a digital twin of a real factory. Okay, so the metaverse is the digital twin of a factory, real. And there you have a so-called emergency user, which is in the digital twin of the real factory, which we call V factory. And this user, the A user is an autonomous user, of course, has the right to actuate and animate an emergency robot in the real factory. So from the metaverse, this user has the ability to influence a robot in the real factory using the process action that I have shown before. And this metaverse user can also be rendered as a persona having the appearance of the robot. If an emergency comes, the emergency user can activate an alarm in the real factory. It actuates an emergency robot in the real factory to resolve the problem, animate the robot, and possibly render its persona so that the employees of the company can see what is happening in the real factory. And when the emergency is resolved, the robot is moved to its repository. So with that, I concluded this presentation. I thank you for your attention, and more importantly, we do look forward to working with you on this exciting MM Tech project. Remember the Mpai motto: join Mpai, share the fun, build the future. And here you have the place where you can find the specification of this new standard. Thank you for your attention.